Now that we know what a frequency distribution is, we're going to look at some additional components that we could add that will help us better interpret the data and ultimately help us when we go on to graphing frequency distributions and making histograms. So the first one we're going to talk about is the midpoint of a class, and the midpoint of a class is the average of the upper limit and the lower limit. So we will take the lower limit and add it to the upper limit, and then we will divide that by 2. So we're just finding the number in between the two boundaries for that class, or the two limits for that class. The next thing we'll talk about is the relative frequency, and the relative frequency of a class is the proportion or the percentage of the data that falls into that particular class. So for example, say that you break your data up into classes and 50% of the data is in the second class, then the relative frequency of the second class would be 50% or 0.5. That's why I'm saying percentage or proportion. The cumulative frequency for a class is the sum of the frequency for that class and all previous classes. So you add up how many are in that class, but you also include how many were in the classes before that. And then that means that the last cumulative frequency would be equal to the total sample size, just adding up all of the frequencies in total. So what we're going to do now is we're going to look at the frequency distribution that we had already created for the cost of medication, I believe it was. So I'm just going to go ahead and fill this out with the data that we already know. The first class had a frequency of 3. The second class had a frequency of 2. And then we're going to go through this frequency distribution and I'll fix that and actually fill out this other data about it. Okay, so we have our classes and our frequencies. We're going to go in and find our midpoints. To find the midpoint of each class, we're going to be taking the lower class limit for each class, which in the first class is 155, adding it to the upper class limit, and then dividing by 2. 155 plus 190 divided by 2 gives us 172.5. You're going to do the same thing with the second class. We get 191. We're going to add it to 226, and then we're going to divide it by 2. 191 plus 226 is 417, and then 417 divided by 2 gives us a midpoint of 208.5. You might notice something. If you look at the difference between the second midpoint of 208.5 and 172.5, the first midpoint, you'll see that I added them instead. You'll see that their difference is actually the same thing as the class width of 36. So once you have one midpoint, you can just continue to add the class width the same way that we were just adding the class width before to find the rest of the midpoints. Or you can just continue to average the lower class limit and the upper class limit and build them out like this. But you should get these numbers for the rest of these class limits. So please check these either by actually doing the 371 plus the 406 and dividing that by 2, or by taking the previous class limit and adding 36. Either one of those will work. You should both end up with 388.5 as your last class midpoint. So now that we have the class midpoints, we're now going to move on to compute the relative frequencies. To compute the relative frequencies, we have to know how many data points are in the entire data set. So the first thing I'm going to do is I'm going to figure out how much data is in this entire data set, and we do that by adding up all of the frequencies. So N, the total sample size, is equal to the sum of all the frequencies F. Just add up all the frequencies F. And if I add up all the numbers in that column, I get a total of 30, which we already knew, by the way, because up here it tells us that we have 30 adults. So that's just another way to double check. So now that we know the total sample size, we can now go on to compute the individual relative frequencies for each class, which we do by taking the frequency of that class and dividing it by the total sample size. So 3 divided by 30 gives us 0.1. that's a proportion. You could say 1/10 is the relative frequency, or you could say 10%. So really either one of those three answers, the fraction 1/10, the decimal 0.1, or the percentage 10% are all correct for the relative frequency of that class. And then we'll just continue computing relative frequencies by taking the frequency, which is 2, and dividing it by 30. Gives us a simplified fraction of 1/15, gives us a decimal of 0.07 when we round, which is the same thing as 7%. So it's telling us what percentage or what proportion of the data lies in each one of these individual classes. So I went ahead and put a few more decimals in there. So for example, down here in the class 335 to 370, it had a frequency of 4. We will take 4 and divide that by 30. And when we take 4 and divide it by 30, we get about 0.13 when I round it to two decimal places, which is 13%. Finally, taking 3 over 30, that's 1/10, that's 0.1. So that is how we compute our relative frequencies. And the last thing we will compute is our cumulative frequencies. So to get the cumulative frequencies, you take the frequency of that class and you add the frequency of any previous classes. So for the first cumulative frequency, there are no previous classes, so I'm just going to be taking the frequency of that class, which is 3. But in the second class, that now has a frequency of 2. So we'll take 2, but we'll add the previous frequency of 3 to get a cumulative frequency of 5. So what that tells me is that there are 5 adults whose cost is $226 or less, right? Because I'm also including anything that came before that. So for the next class, we would take this new frequency of 5 and add it to the cumulative frequency from before that to get 10. Then I'll take the new frequency of 6, add it to all those before to get 16, and I'll just continue adding these out. We would add 7 to get 23, we would add 4 to get 27, and then finally we would add 3 to get 30. And a double check is that that last number should always be the same as your total sample size, which we can see that it is.